Hello there and welcome back to, I don't even know which video this is now. This thing is number 5. We're going to compare all the sales people. Now I'm going to think about their total sales between a certain date range. So I have prepared this function here called compare all salespeople. I don't think I've got a function anywhere. No, I have. I made one, put a print statement in, remember? I don't need that. Analyze individual sales, I don't need that anymore. But compare all salespeople. This is what I want to do. Now, my computational thinking strategy is kicking in already, and I'm thinking, right, first, I need to load the CSV, like get the raw data in, clean data. After I've done that, we need to get the date range and then convert it to a proper date structure. That will work with what's it called? Matplotlib and Panda data frames. So get it from a string, get it as a proper date format so we can do things with it. Okay, then we're gonna filter. Actually, that I'm gonna try and keep this really modular for you and try and break it down as much as I can. So I'll show you these steps individually. Convert it to a proper date structure. Then we're gonna filter by the date range that we've just figured out. So that's me making that mask again. Then I'm going to group. I've got 4 salespeople, I think it is. I'm going to group all of their sales by the salesperson and add it all up so we've got a total amount. So group by salesperson and sum the sales, add them all up. All right. Output the results. That we'll do that textually, and also we'll do the same as I've done all the way through. That is, do it graphically as well, right? So output the results and then output on a graph or something like that. And what have we done so far? We've done a bar graph, done a scatter graph, no, we didn't do a scatter graph. We did a line. This might be better suited as a bar though, because we've got like the total amount. So let's just get cracking. Data frame equals pd.read csv open brackets. I can't remember the name of it, but it's there in the top corner. Task 4a underscore data dot cs. Oh no, dot csv. Right, there it is. Wonderful. Import, no problem. Get the date range. I've done this already. Let me steal it. There it is. Stolen. Get the date range. There we go. Saving time. Convert it to a proper date structure. I did that as well, didn't I? I did that as well. Oh, I did. This one? This does almost. So, when we're converting it to a proper date structure, I don't know what extract is because I'm dealing with df. df is my data frame. So df date, so go into the date column in your data frame, and then pd dot to underscore date time. Extract doesn't work again because it's not called extract, it's called data frame. And then comma format. So this, I'll just put a comment here, formats the date column. Formats the date column. In addition to that, I also need to make sure that start date is also the right format. So I'll use the same thing here. Date time, open brackets. Now I'm not passing my data frame in, I'm passing in start date, the string, right? But I do need the back end, the format bit, make sure they all match. So this ensures that my data frame column, my end date, my start date are all the correct formats. Oh, screwed the pooch on that one there, John. There we go, that one. Perfect. Formats the date column, formats the start date, and formats the end date. Let me just put that back in there. End date. Nearly went wrong there, but never mind. Right, wonderful. Now, the dates are correct. I need to produce and create the mask. The mask is the overlay that's going to filter my data frame down and get rid. So df, square brackets, date. Take the date column. Check each row to see if it's greater than or equal to start date. Okay. What I'll do is just so we don't get confused, I'll just take that out and I'll just take that out. So we've got start and end, right? So you can see that I'm using start now. There. Outside the brackets, we do the same thing, ampersand, which means and. Date goes in here. Date. Less than, equal to, end. Oh, dearie me. So your mask is where your date column is greater than equal to start and the date column is less than or equal to end. Filtered data frame is going to equal df.lock. Remember, lock is based on a string of some, or like a string label, not an index, I suppose. And we're putting there mask. Okay. Now, if you printed out filtered underscore df, you would see just the date ranges that you've specified. I'm not going to show you because time. So now we're going to group by salesperson and sum the details. Call this sales summary equals. So we use the filtered data frame now because it's got the date range that we want. We use the group by function and we're going to group it by salesperson. Just going to check that that's correct. Salesperson, yes, capital S, lowercase p, salesperson. Now, once we've grouped by salesperson, we're going to take the value again, and we're going to use exactly what they've used, Pearson have used in the code, sum bracket bracket. And we're going to leave it like that. Okay. Output these results. Print. Why are we using print statements, John? Well, because we're using meaningful outputs because we want that top band. Yes, we do want that top band. \n, new line. Total sales for each sales person from. So we need start date to end date. Put another new line in it. For. Now, interestingly enough, watch this. I'm going to write this and then I'm going to explain it. Now, what is that doing? Okay, for name and value in sales summary items. Okay, what that says is for each name and value in sales summary, print one by one. So it will go through the list until it reaches the end, and it will output name and value. Now you think it's going to output all the names over and over again. No, because we've used a group by, we have grouped the names down. There should only be 4 rows. There should be Michael Garcia and Chris and Sarah and the other person I can't remember. They will output 4. That's 4 things that'll output. That's it. Right? That's what it's going to do. Now, does it? That's the question. Oh, well, we probably should test it. We should have tested it ages ago, to be fair. No doubt this is going to break on me now and make me look silly again. So let's go trends and patterns. Let's go compare salespeople. Start date, the 1st of the 9th, 2020. John, there's no 2020s in your list, man. Control C, cancel, keyboard interrupt. Let's try again. Ah, dearie me. It's been a long day. Salespeople, start date, the 1st of the 9th, 2024. 20th of the 9th, 2024. There you go. 4 people. They've got total amounts. Each person's the sum of how much they've earned in sales, not how much they've made in sales. Now, the trick is, can we output that in graphical format? PLT dot figure. Same process. Fig size. I use 10 and 5 and it seems to serve me well, so I'll continue to use it. I told you before, what data do you want to plot? Sales summary dot plot. Plot the sales summary. And what kind of chart do we want? I'm going to go for bar this time. And second to that, what color do we want? Let's go for teal. Teal color. Pretty teal. And once you've done that, I always just do plt.show. I've not done any titles or whatever yet because I just need to prove to me that the data is actually going to work, because these things have a habit of hating me, which is okay. Salespeople. First 20. Where's 20? 20. Yeah, okay. Oh, that was better than I thought. Hey, look at me doubting myself. Right, plt.title. Let's do an F string and say total sales by sales person. And let's go start date. Start date in there. To end date in there. Wrap it in a little bracket outside that one. Wonderful. So you got your title, you got your PLT dot X label. What's on the X axis? That's the name, isn't it? The name of the person. Salespeople, sorry. So this is sales. I type always. Sales person. What's on the Y? Total sales in pounds. So my X ticks. It's the words on the bottom. Rotation. It's all the same as before. Once you've got one of these down, you're laughing. Rotation, 45 degrees. PLT dot tight layout again. Squeezes it all together. Tight layout. Should we do a grid again? Let's do it. I'll tell you what, we'll do a grid, but this time I'll show you what this does. So axis, you can either have X or Y or both. If you leave this blank, it will show both. If you don't leave it blank, see that says both. you can just put, let's just put y-axis on there. Let's see the y-axis, can't you? There you go. Right, okay, run this. Number 3, compare salespeople. Let's go first. And there you go. Christopher, David, Michael, and Sarah. Christopher's obviously winning in terms of sales. You know what? I'll show you one more thing, because wouldn't it be nice if we could order these? Let me add this in here. Where would it go? So you've got sales summary filtered. So when you group it like this on the sum, if you put a full stop there and type sort values, you can add in what's it called? Ascending or descending. Yes, so ascending, you can either flick it to true or false. Okay. Now, if you watch what happens from this line that I've added, let's run it again and let's see what happens. 3, 2, first 20. There you go. Now, if I change descending to true, you could probably guess what would happen there. David would be on the left-hand side, followed by Sarah, Michael, then Christopher. So it would be in ascending, because it's true. So lowest to highest instead of highest to lowest. Okay, but there we are. All right. Now, what would I do now? So I would spend my time ensuring that everything has a meaningful output. Okay, a meaningful output. And I would ensure that I have commented my code and made it robust in terms of making sure that no one can break it, basically, right? So from the top of my code, I have added in extra menus as I scroll down. Menu 2, menu 3, menu 4, selecting sales people. Done quite a lot in that one function. I would prefer to break that up. I have compared all the sales people. Again, I can break that up, but I was just tight for time. I've used what the exam board already provided for me to my advantage, and then I've applied my own knowledge as well. And I've done graphs in each stage so you can see how I've done that. The process is the same every single time. Every time. It's just remembering the first steps. If you can't do all the fancy stuff that I did in terms of adding all the extra stuff, just remember, you've got to plot it and show it. That's it. Plot the data, show the data, and it will show something at least. Okay? Now, if you've made it this far, you deserve a little insider tip, don't you? In terms of what the task 4A is actually looking for. So let's have a look at this. If you look at the mark scheme, you can see it is out of a number of different assessment foci. You've got functionality, logic and programming structures, robustness and security. If you look at the bands, the highest on there is 6. So the solution implements functional and efficient code throughout. It's precise programming logic. The code handles common and most unexpected user errors. Everything goes in a loop. That's the answer to that. The code thoroughly mitigates against relevant vulnerabilities. And then if we move on just a touch in here, you can see that the code organization and user experience has the highest marks. So the code is easily maintainable by a third party, so consistent and appropriate naming conventions. So proper naming conventions in snake case all the way through. Highly informative commenting. Excellent user experiences provided, so input handling, user guidance, error messages, things like menu numbers, enter this, is this your choice, sorry you got that wrong, try again, etc. When I go through the examiner report and I have a look at it, basically you're looking at a lot of waffle. But if I boil it down, to what the task is actually asking you for, the students develop a working program. Expected to use Pandas, Matplotlib or Python in the core features, and you need good coding practices. So here, skip on a little bit. Many students in the 2024 had a strong understanding of input validation. They were aware of how code maps to given scenarios, and they were able to offer multiple options and adapt what was going on for the user in terms of what was already provided. The problem that we found in 2024 was that some code was non-functional, so it had major errors, didn't quite work. The majority of students were still unfamiliar with the main package, Pandas, and also Matplotlib. So manipulating data frames and then plotting on graphs or doing graphical plotting. Okay, date manipulation specifically, which is why I've included it in this tutorial, that was also a problem. Now there's no need to do any login, any access to anything. There's nothing like that needed at all in this task. So what do I recommend? Start simple, get one requirement working, build on it, use what's already there to help you as much as possible. See how they filtered people and adapt it. Practice date filtering and manipulation using date time. Getting those dates correct, because all the task 4As that I've seen usually have dates either in a column or as row headers. I saw one year where the row headers and it threw everybody. Constructing separate data frames is always the way to go. Do not edit your original data frame ever. Using error handling, try catch exceptions, things like that, and returning helpful messages is the way to go. In the bottom there, I've put best coding practices to follow. So avoid using global variables. I've not used a single one in mine. Pass data between functions cleanly, which I've done. Generate new data frames, which I've done. Handle errors, which I have also done. Everything's in a while loop. Ensure menu options are relevant and clear. I've got menus everywhere and submenus, and use meaningful variable and function names. Well, I've copied Pearson, so if you fault me for that, then it's on you, isn't it? And then commenting, that's the only thing I didn't do throughout the whole of this. I did some commenting, but I would go back and add all that commenting in. And my advice is do it as you go. Don't leave it to the end. Okay? And that's it. That's it. That is my tutorial on task 4A. If you want that code base, just get in touch, jbr@osfc.ac.uk, and I'll send it over.